Hello, my name is Andrew Wood, and this is the Physics 2212 Lab 1 charge tapes. Introduction. The purpose behind Lab 1 is to create charged pieces of tape, and using said pieces of tape, find the amount of charge that the tape has. This will be tested during the experiments performed. GlowScript will also be used as a tool for modeling the tape experiments and for computation of questions. Computational results. The electric charge of the tape was 1.75 e to the negative 9 coulombs, and the pieces of tape were missing 1.09 e to the 10 electrons. Physics principles. Some of the concepts in this lab are Newton's second and third laws, with the second law being force equals mass times acceleration, and Coulomb's law. Um, Coulomb's law K is 9 billion, Q1 is the charge of the first point, Q2 is the charge of the second point, and R is the distance between the two charges. There will also be the property of matter that like charges repel while opposite charges attract. Experiment. Interacting two charged tapes. Hypothesis. If I were to bring two U tapes next to each other, I would expect that they would repel from each other because they have the same charge and like charges repel when experimenting. The two charged pieces of U-tape repelled each other when brought together. This must mean that both pieces of U-tape have the same charge. When brought near a neutral table, the piece of the U-tape was attracted to the table. This does not show if the charge is positive or negative because both can be attracted to neutral objects. Experiment determining charge. To determine the charge of the tape, we must answer if the U-tape is positive, then when brought near the negatively charged plastic pen, it should attract. If the U-tape is negative, it should repel the negatively charged plastic pen, and if the U-tape is a neutral charge, then would still be attracted to the negatively charged plastic pen due to the temporary dipoles created. When tested, the piece of charged U-tape was attracted to the plastic pen, therefore the charge on the piece of U-tape must be positive. Experiment, floating tape. Some tape properties I had were the length of the U-tape was 20 centimeters, the mass of the U-tape was 0.2 grams, and the width of the U-tape was 2 centimeters. For this experiment, the system will be tape B and the surroundings will be tape A along with the supports. Because the momentum of tape B does not change during the experiment, this must mean that the force of gravity is equal and opposite to the electric force repelling the tapes, and the net force is zero. Floating tape continued. The distance when tape B started to float was 0.375 centimeters. The magnitude of the gravitational force was 0.00196 newtons and found by using force equals mass times acceleration. We can plug in 9.81 for acceleration and 0.002 kilograms for the mass. Because the net force of the tape B is zero, the electric force must be the same magnitude as gravitational force. This means the electric force is also 0.00196 newtons. For these calculations, we must make assumptions about our materials. Air resistance can be ignored because tape B is static. We must treat the strip of tape as a point charge, with the charge being located at the center. We must also assume that each piece of U tape has the same amount of charge. GlowScript code and calculations. Using GlowScript and Coulomb's law, I was able to calculate electric force upon tape B in line 8. This is 1.75 e to the negative 9 coulombs and was found using Coulomb's law. I then calculated the number of electrons missing from the U-tape, which was 1.09 e to the 10 using the formula. Number of electrons missing is the charge of the electric field over charge of electron. Because electrons are negative and we prove the U-tape was positive, the U-tape must be missing electrons. Finding the area of one piece of tape, which is length times width, and in my case 0.004 meters squared, we can then find the amount of atoms on the piece of tape under the assumption that an atom is 1 times 10 to the negative 20th meters squared. I then divided 0.004 by 1 times 10 to the negative 20th to get there are 4 times 10 to the negative 7 times 10 to the positive 17th atoms on the U-tape. To calculate the number of deficient electrons per atom, we divide the number of electrons by the number of atoms to get there are 2.725 e to the negative 9 electrons per atom. Errors. Some sources error in my experiment. Loss of charge due to the interaction with the tape. Loss of charge due to the support interaction with the tape. The charge of both U-tapes are not equal to one another. During the experiments, the U-tapes did not behave like points, unlike our calculations, and the humidity and temperature at the time could have affected the strength of charge. What if? Nothing in this experiment would have gone differently if the electrons had positive charge and the protons have negative charge, except the pieces of U-tape would no longer be attracted to the negatively charged pen. Similar charges would still repel and opposite charges would still attract. Why? It is important because our hands are not insulators, unlike the tape, and the charges will migrate off the pieces of tape if they come into contact with other objects, decreasing the charge of the U-tape. I'm Andrew Wood, and this was my Physics 2212 Lab 1 report.